This conference will now be recorded.
Hey, hi guys. So today onwards we're going to talk about Spark. Again, as I told earlier, Spark is very important in the interviews in the projects. Wherever you go, most of the weightage will go to Spark. At least 70 to 80% of the questions in the interviews will come from Spark only. So if you can master Spark, it becomes very easy to get the job as well. So that is a secret. So let's get started. So let us say that I have a single computer or a single laptop. So that is good enough for me to watch the movies or play with any spreadsheet or an Excel sheet. But the problem comes when if I have to use the single computer or laptop to deal with big data, because we cannot store big data on a single computer or on a single machine. So that's what is called as big data problem, right? Now we already know the solution as well. The solution to deal with big data problem is called as Hadoop. So in Hadoop version 1.x, we have only two components, HDFS and MapReduce. But in Hadoop version 2.x onwards, we have three components, HDFS, MapReduce, and we have a third component called as Yarn. So what is HDFS? It is a distributed storage where all the big data is stored. And once the big data is stored, to process the data, now when I say process, it is not, I'll take a simple example first of all. Let us say that we wanted to find out the top 5 selling products in Amazon in the year 2021. So the first step is you have to get that data. We call it as big data. Now once you get the data, you have to process the data. That is doing some operations on top of that data to figure out what those top 5 selling products are in the year 2021. So which component will do that processing for you? It's nothing but MapReduce. MapReduce is the computing framework or the data processing framework to process your big data. And then we have the third component called as Yarn. Remember, in Hadoop version 1.x, we have only two components, HDFS and MapReduce. But from version 2.x, we have third component called as Yarn, where Yarn stands for yet another resource negotiator. Let me write it down here. A lot of people are not aware of the full form, but it is important to remember the full form as well. Yet another resource negotiator. So that is the full form of Yarn, and it is actually nothing but the resource manager in the big data world. So we'll get into Yarn shortly, but remember that to deal with the big data problem, we have the Hadoop as a solution, where in Hadoop version 2.x we have these three components: HDFS, MapReduce, and then Yarn. So we'll talk a little bit about Yarn now. First of all, the full form of Yarn is yet another resource negotiator. So to keep it in simple terms, Yarn is actually equal to the operating system on your laptop, such as Windows is an operating system. So Yarn in Hadoop is actually nothing but the operating operating system, right? So it could be Windows or it could be Mac OS or anything, but the conceptually it is same. Yarn in Hadoop is actually equal to an operating system such as Windows or Mac. We'll get into more details shortly. So let's say that I have this big data cluster where I have couple of master machines. You can see on the right hand side we have master machine where the name node is running. On the left hand side we have other master machine where resource manager is running. Because in Yarn it also follows this master and slave. In Yarn, master is nothing but the resource manager. and the slave is nothing but the node manager, right? So if you recollect in HDFS, what was the master? It's nothing but the name node. And then what was the slave? Nothing but the data nodes. Conceptually, it's almost the same. In Yarn, the master is nothing but the resource manager, hence it is running on the master machine in the cluster. Node manager is the slave, hence it is running on the worker machines or the slave machines in the cluster. As you can see here, on all the slave machines, data node and node manager are running together. Now I wanted to store my data, basically my big data. So the data is stored in the form of blocks, as you can see here, block 1 and block 2. And now suppose let us say that we have written a program in MapReduce Java to figure out the top 5 selling products in Amazon. Again, we don't need to learn anything in Java right now, but just conceptually understand that we have written program in MapReduce in Java, and we have packaged that code as a jar file that you're seeing it as my Hadoop app. So my Hadoop app that you're seeing right now here, it could be MapReduce program, and this my data that you're seeing here could be Amazon sales data for the year 2021, because this code should get the input as the data and then it will process the data, right? So that is where whenever we submit the job to the cluster, the first point of contact is nothing but the resource manager, because the reason is in Yarn the master is nothing but the resource manager. So the first point of contact is nothing but the resource manager. So what resource manager will do? Resource manager will create something called as application master. So here I want to give one more simple example. Suppose let us say that I wanted to watch a movie on my laptop, right? So now where will the movie be stored? It will be stored in the hard disk of your laptop, right? But to play the movie, you need some player, right? You need some player such as Windows Media Player or VLC player is required. So once you start playing the movie, what will happen? The movie gets copied from your hard disk to the RAM, and then movie starts playing. So here in this example also, if you can think of this MapReduce job as your movie, to execute this job, we have something called as application master. So you can think of this application master as nothing but your player, VLC media player or Windows media player, whatever it is, right? And once you start playing the movie, but again to play the movie, we need some resources. What are the resources that we require? We require hard disk to store the movie, and we need RAM to get the movie copied from hard disk to RAM, and we need some CPU processing capability as well. So similarly, to execute the submitted MapReduce job also, we need all the resources. Who is going to provide all those resources for us? It is nothing but the resource manager. But now the first point of contact is nothing but the resource manager. Resource manager will launch the container called as application master. What is container? Container is nothing but group of resources. Group of resources put together. So what application master will do is application master will go and contact the name node to figure out where the data is stored. So you can see here the request is going from the application master to the name node, because application master takes the complete responsibility in executing and monitoring the submitted job. So as a response to that, name node is saying, okay, the data that you're looking for is available on node 1 and node 2, right? You can see block 1 and block 2 are available on node 1 and node 2. Now application master is completely aware of where the data is stored. What application master is going to do is, application master will make a request to the resource manager saying that, okay, on node 1 I need 1 GB RAM, 1 CPU core. Similarly on node 2 I need 1 GB RAM and 1 CPU core, because that's the place where the data is stored, right? So the application master will request the resource manager for the resources of the containers so that he can start map and reduce tasks on those containers. As a response to that, resource manager says, okay, whatever containers that are required for you, all those are granted or allocated for you. Once the containers are allocated by the resource manager, the application master reaches out to the node managers to launch the containers and executes those tasks. So within those containers, the map task and reduce task will actually process your data. And finally, all those containers are killed or terminated automatically, because once the movie is done, the player gets closed automatically, right? Same thing is happening here. Once the data processing is done, once we're able to figure out the top 5 selling products in Amazon in the year 2021, all the containers are killed automatically, right? And finally, the acknowledgement goes from application master to the resource manager. So the tasks directly report back its status and progress to the application master. Once all the tasks are complete, all the containers, including the application master, gets terminated. Because the goal of application master is to execute the submitted job. Once it is done, that will be terminated automatically. It is similar to that once you start playing the movie, the main role of the player is to play the movie. Once the movie is done, the player gets closed automatically. The same thing is happening here. So the
Hello.
same thing. Go ahead, please.
Yes,
Any
I
question?
have a question.
Go ahead, go ahead.
Yeah. What is a container here?
Container is nothing but a group of resources put together. So whatever resources that are required to execute your submitted job, when I say job, it is nothing but the code that you have written. It would require hard disk, CPU, and RAM to process the data, right?
Hmm.
So you can think of
Yes.
container as a group of resources put together.
Okay.
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 Yeah.
Yeah, thank you.
Yeah. So the same thing is applicable in Spark also. So in Spark also, suppose you have submitted your Spark job. The first point of contact is resource manager. It will create the application master. Again, application master will contact the name node to figure out the location of the data. Then it will request the resource manager. As per the resource request, resource manager will allocate the containers. Now within those containers, executors will run. Executors will start running and it will process your actual data. So again, we haven't spoken about executors yet. Don't worry about it for now. But this is the overall flow that I'm talking. Because in the interviews, you may get a question such as, what happens when you submit a MapReduce job, or what happens when you submit a Spark job? So this flow is important. So now the third component is nothing but MapReduce, right? So we are aware of HDFS. We have seen Yarn. Now I'm going to talk about MapReduce a little bit. So the main difference between MapReduce and Spark is, with respect to MapReduce, everything is happening in hard disk. You can see here, we are reading from hard disk, writing again back to hard disk. That is a problem, because reading from the hard disk or to the hard disk is always a costly operation. Hence, we will actually uh, won't prefer using MapReduce because of its slowness. We will go with Spark, because in Spark, only for the first time we will read from the hard disk, and all the intermediate data is stored in the RAM. Have a look here. All the intermediate data is stored in the RAM. But whereas coming to MapReduce, even the intermediate data is also stored in the hard disk. That is a problem. Reading or writing from the hard disk onto the hard disk is always a costly operation. But Spark is very smart. Only for the first time it will read from the hard disk. All the intermediate data is stored in the RAM. That is in the memory. Now, if you can think of this blue color rectangle as hard disk or HDFS, for the first time, map task will read the data from hard disk. It will do some processing. It will push the process data into the hard disk. The output from map task will go as input to the reduce task. If you want to achieve something, let us say if it is taking 12 plus disk IO hits. What is disk IO hits? IO is nothing but input output. Disk input and output, that is reading. Disk input is nothing but reading from the hard disk. Disk output is nothing but writing to the hard disk. Always reading from the hard disk and to the hard disk, writing to the hard disk is always a costly operation. If you want to achieve the same thing in Spark, you can do that with just 2 disk IO hits, because only for the first time we are going to read from hard disk. All the intermediate results are stored in the RAM itself, and finally we are storing the results back onto the hard disk. So now we will talk about the differences between MapReduce and Spark. So this is again very important, guys. So generally whenever the interview starts, it will start from basic, slowly they'll get into the advanced concepts. So this could be your first question in the interview. What is the difference between MapReduce and Spark? So MapReduce is only for the Java developers. If you know Java, only then you can work on MapReduce. But Spark is very flexible. You can write the code in any language. You can write the code in Java or Scala or Python or R or SQL. You can write the code in any language. And also, because we need to write the code in Java and MapReduce, it involves boilerplate coding. That is, even if you have to achieve a simple thing, you have to write lot of code. But in Spark, we can write the code in clear and concise manner. That is, by writing less code, you can achieve more. And there is no interactive shell in MapReduce. But whereas in Spark, we have an interactive shell called as REPL. Read, evaluate, print, and loop. So I have already set up Spark on my laptop. I will show the REPL now. I'm opening command prompt. Here I'm going to launch PySpark. So now you can see that the interactive shell has been launched. Now, why are we calling it as REPL? Because it's going to read the code that you have written, it's going to evaluate, and then it's going to print it and then loop it. So let me say print hello world. You can see first it is reading the code, it is evaluating the code, and then it is printing the code, and then it is looping. Basically, it is waiting for the instructions to be given by the user. So that is why it is called as REPL. Read, evaluate, print, and loop. Basically, you can explore the code line by line in Spark by using REPL that I've just shown you. But that flexibility is not there in Spark. In MapReduce, we don't have any interactive shell in MapReduce. And coming to MapReduce, it is all disk based. As I told, it is very slow. Coming to Spark, it is memory based, and everything is based on RAM. It is very fast. And coming to MapReduce, it is only meant for the batch processing. Now, when I say batch processing, you'll be getting the data at regular intervals. Suppose you might get the data on daily basis at 11 o'clock in the night, or you might get the data on weekly basis on, let's say, every Sunday, or you might get the data on monthly basis, let's say first day of every month. So the example for batch processing is your mobile bill or your internet bill, which gets generated every month once. Whereas coming to Spark, it can do both batch as well as interactive processing. So what is interactive processing? Interactive processing is also called as a real-time streaming processing. So if you take Uber is an example for the interactive or real-time processing, because the moment when you start placing a request for a cab should be booked within a span of 1 or 2 minutes of time, right? So that's an example for your interactive or real-time data processing. So you can ignore last 2 points. So if you get this question in the interviews, if you can explain 2 3 points, that should be more than enough in the interviews. The point is very clear. It all went to the downfall of MapReduce. Now Spark is the very widely used data processing framework in the big data world. And even in the interviews, if you get a question such as, have you done coding in MapReduce? You can say that you haven't done coding in MapReduce, and that is not expected as well because MapReduce is outdated and nobody is using MapReduce these days, right? Now we have touched upon the three components of Hadoop version 2.x: HDFS, MapReduce, and Yarn. Now I wanted to go back to my initial question that I've asked. So the problem is, if I have a single computer or laptop, I can watch the movies or play with Excel sheet or do whatever I want to, but I cannot deal with big data because I cannot store the big data first of all to process it. So what is the solution? The solution is nothing but a cluster. A cluster is nothing but a group of computers that are connected together. So I cannot store the data on a single computer, but I can store the data across multiple computers by breaking it down. That's where the solution to the storage problem is nothing but a cluster. But just having cluster is not enough because we need to have a mechanism where all those machines communicate together or coordinate together. Now, that is where we need a framework called as Apache Spark, which does the exactly the same thing. So MapReduce was uh, was initially used, but now MapReduce is outdated completely. It has been replaced with Spark. So Spark is the distributed data processing framework. Now, why am I calling it as distributed data processing framework? Because the data is distributed among all the worker machines in the cluster. The formal definition of Spark is the fast general purpose engine for large scale data processing. Under the hood, it works on cluster of computers. Now, let us look at the components and libraries in Spark. So you have to read this from bottom to top. So you have the compute cluster, and you have the green color block that you're seeing here is called a storage layer, where you can store your big data in HDFS, or if you're using Amazon AWS services, then you can use S3. S3 is nothing but simple storage service where all the big data is stored. If you're using Azure Cloud, you can store your big data on Azure Blob. If you're using Google Cloud, you can store your big data on Google Cloud System. And if you're using any NoSQL database such as Cassandra, you can store your big data on Cassandra file system. So this green color block that you're seeing here is representing the different ways of storing your big data. But the popular choice now is HDFS or Amazon S3. S3 stands for Simple Storage Service, where all the big data is stored. Then on top of it, you have the resource manager such as Yarn or Kubernetes or Mesos. So these are the three options that are available for you. One of these can be used as your resource manager, but the popular choice is again Yarn, yet another resource negotiator. Then we have Spark Core. As I told, we can write the code in Spark in multiple languages. Guys, sorry, there was a network problem. I'm back now. Sorry for the interruption. Can you hear me now? I'm audible.
Yes,
Yes.
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 Thank you. So yeah, I was talking about the language support. So you can write the code in Spark in any language, Scala, Java, Python, and R. But the most widely used option these days is nothing but Python itself. Hence, we have learned Python. And then you can write the code in simple SQL also. We'll also see that as a part of our hands-on. And we'll also write the code in something called as data frames. You can think of data frames in Spark is similar to tables in a database. Then with respect to Uber example that we just spoke about, so Spark structured streaming is used by Uber quite a lot to handle the client requests coming in Uber app. And then we have support for machine learning as well called as MLlib and graphics to do the graph processing. But again, these are not used much in the industry, right? We'll not worry much about MLlib and graphics. Those are kind of not used. So, but we'll talk about all the rest of the things. So now in Spark also it follows master slave architecture. That's a very interesting again. So in Spark also we have master and slave. Master is called as driver, slave is called as executor. Right, so guys, you have to remember this. So sometimes when I take the interviews, if I ask these fundamental questions, a lot of people are not aware of these. And if you miss out this, definitely that's not going to leave a good impression. So very, very important to make sure that you guys are very, very strong in these fundamental concepts. So in Spark also it follows master slave architecture. Master is nothing but the driver and the slave is nothing but the executor. So I have a look here. We have master and then we have bunch of slaves. So driver is going to act as master, bunch of executors they are going to act as slaves. Now Spark is a distributed processing engine. It again follows the master slave architecture. So every Spark application will create one master process and multiple slave processes. So remember one interesting thing, the data processing won't happen on driver. So data processing is not done by the driver. So data processing is taken care by the executor. So remember this concept. So data processing won't happen on the driver. Always the data processing is taken care by the executors. So executors are responsible for actually carrying out the work that the driver assigns them. So executors are the processes running on the worker machines which will do the actual data processing for you, right? So you can think of this as, right, so in some projects the technical leads won't do any coding, right? So they'll just take the work, assign it to all the team members. They won't do any coding. It's the actual team members who will develop the code. But whereas the technical leads will review their code, right? They'll give some suggestions on the inputs. Same thing is happening here. So driver will take the work, will assign it to the executors. Executors will take care about executing and processing the data for you. Then one of the very common interview question is, how are you going to submit your Spark job? Now, whenever I say Spark job, job is nothing but the code that you're going to write. So what happens in the projects is we package the code as a single file, such as jar file or wheel file, and then we will submit that Spark job to the cluster by using a command called as Spark submit command. So the interview question might come as, okay, can you tell me the command that you use to submit the Spark job? The answer is Spark submit command. So here, as you can see, we are first packaging our Spark application or Spark project, and then we will submit the Spark job onto the cluster. And always remember, as a developer, we will have access only onto the client node or the gateway node in the cluster. Client machine is also called as gateway node in the cluster. As a developer, we will not have access to the entire cluster. We will have access only to the client machine or the gateway node that you are seeing here. Internally, the Hadoop admin will configure the communication between the gateway node and all the name nodes and data nodes and all that. That is admin related activity. We don't need to worry much. But as a developer, we'll have access only to the gateway node or the client node. And when you submit your Spark job, you create a respective driver and then bunch of executors. Suppose if you submit another job, you will have bunch of drivers and executors running together, right? So it is something similar to that. If you have a team of let's say 20 members, let's say you have two technical leads. One technical lead will take care about 9 members. Other technical lead will take care about remaining 9 members. It is something similar to that. So this is the architecture of Apache Spark. Very simple architecture. You can see that you have your driver program, which is running on the master machine. On all the worker machines, you can see that you have the executors running. And you can see the cluster manager here that is in between. What is cluster manager? It is nothing but yarn. Cluster manager is nothing but yarn. And you can see something called a Spark context here. So Spark context, you will get it automatically. If you can go back here, if you type SC, type of SC, that is nothing but the Spark context. So this is what is going to act as a bridge between your driver and then the cluster resource manager. So Spark context is going to act as a bridge between the driver and the cluster resource manager such as Yarn. And then the worker machines will have the executors running. You can see on all the worker machines we have the executors running, right? And one important concept that you have to remember here is, so Spark job has been broken down into stages, and stages are further broken down into tasks. Right? Again, we'll get into the hands-on of these, but for now, remember this hierarchy. Job contains multiple stages, stages contains multiple tasks. So that's what you are seeing here in this architecture. And I told that Spark stores all the intermediate results in the RAM, right? So that's what this cache is representing. It's going to cache all the results. So that's why Spark is 10 to 100 times faster than MapReduce, because it will cache the intermediate results in the RAM or in the memory. So in the interviews, you may get this question: what is Spark context? So Spark context is the main entry point for the Spark functionality. You can think of it as similar to a database connection. So if you are aware of databases, what you generally do is you try to create a database connection first, and then you run all your commands, right? All those commands will go through that database connection only. So similarly, anything that you do in Spark, it actually goes to the Spark context. Again, if you don't have any experience towards working with databases, don't worry. For now, you can just think of Spark context as the starting point to deal with the Spark applications. As I told, Spark context is going to act as a bridge between your cluster manager, which is nothing but YARN, and then the driver to negotiate the resources that are required from the cluster manager. So Spark context is a single point of contact between your driver and then the cluster manager. So one of the again common interview question is, what are the different cluster managers that can be used in Spark? The answer is, there are totally 4 cluster resource managers that you can use. You have standalone cluster manager, Apache Mesos, Hadoop Yarn, and then Kubernetes. But again, in the real-time projects, we will not use standalone cluster manager. Apart from standalone cluster manager, rest of the 3 are equally good, but the popular choice is Yarn. Yarn is the most widely used cluster resource manager. Remember, standalone cluster manager is never used in the projects. It is only for the learning purpose. Standalone cluster manager is never used in the real-time projects. It is mostly the Hadoop Yarn which is actually popular as a cluster resource manager. Any questions till now, guys? Anybody have any questions so far? Before moving on, any questions? I'll wait for a couple of minutes. Okay, I think we are good. There are no questions. Let's move on. Now, as I told, this is the hierarchy. You have the Spark application, which is nothing but your Spark project, and you have Spark job broken down into stages and broken down into tasks. Now, the question is based on what and based on how we are dividing the job into stages and stages into tasks, right? So that we will see practically. But for now, just remember this hierarchy. Spark job contains stages, stages contain tasks. As you can see here, an app contains multiple jobs, a job contains multiple stages, a stage contains multiple tasks. Executors will run those tasks. The whole Spark job has been divided into stages. Each stage has been further divided into tasks. So what is task? Task is nothing but the smallest unit of work that the driver sends it to the executor. So these tasks are executed on the executors on the worker nodes. That is, task is executed by a thread in an executor on a worker thread. I know the last statement is very confusing, but I will make it clear for you. So to talk about this last statement, I should be talking about certain fundamental concepts here. So I hope you guys are aware of differences between the process and the thread. If not, I'll cover it now. So what is process and what is a thread? So suppose if you can think of this, if you can think of this square that you're seeing here as nothing but my laptop, right? So let's say that on my laptop I have one process running, which is nothing but, let's say I have opened YouTube. Let's say I'm watching some YouTube videos, right? That is one process. And let's say I have another process running. It could be like, let's say MS Word document. I'm trying to prepare a document, right? And let's say the third thing could be, let's say I have some music player running in my background, right? So on a given laptop, you have three processes running simultaneously, right? So suppose if I take within each process, you have multiple threads running. Suppose if I take YouTube, may have one thread which will be taking care about the video duration. There could be one thread which will be taking care about the video audio, right? There could be another thread which will be taking care about the subtitles of a given video. And if I take the second process, let's say MS Word document, I may have one thread which will be taking care about the font size. There could be one thread which will be taking care about the font color. There could be another thread which will be taking care about the spelling check. Then I may have this third process where I have an audio player running, which will be taking care about the audio duration, and another thread which will be taking care about basically the a lot of other things can be taken care, right? So the point is very clear. On a given laptop, I have multiple processes running simultaneously, right? So similarly, within each process, you have multiple threads running. And if you can think of this square box as your worker machine, on a given worker machine, you may have multiple processes running, and that process is nothing but the executor. You can think of this process as nothing but your executor, because executor or driver, they are nothing but the Java or JVM processes. So driver and executor, they are actually nothing but the JVM process, Java processes, right? So on a given worker machine, you may have multiple executors running. An executor is nothing but a Java JVM process. Now within each executor, you have a thread, and the name that is given to the executor thread is called as EC, executor core. Executor core is nothing but the thread of the executor. Now, if you think about the Spark job hierarchy, you have Spark job broken down into stages, stage broken down into tasks. Where are these tasks executed? These tasks are executed on the executor core of the executor. Now, where is this executor running? This executor is running on the worker node or on the slave machine. So this is the fundamental concept that you have to remember, guys. Very, very important again. On a given worker node, you may have multiple executors running. Within each executor, you'll have multiple executor core, which is actually nothing but the thread of the executor process. And with respect to Spark job hierarchy, we have Spark job contains stages, stages contain tasks. Each task will go and run on the executor core of the executor. So any questions in this specific slide? This is very important. I can clarify if you have any questions. Let me repeat it again. On a given worker machine or on a given slave node, you may have multiple executors running, which is nothing but a Java JVM process. Within each executor, you have multiple threads running. It is nothing but the executor core EC. And if you talk about the Spark job hierarchy, job contains stages, stages contain tasks. These tasks will go and run on the executor core of the executor. I believe we are good. Now we will go back to the previous slide and read the statement once again.
One second. Actually, so from the executor code, they would go to the worker nodes.
Executor cores are running on the executor process. Executor processes are running on the worker node in the cluster.
Okay, executor processes are running on the worker nodes in the cluster. Okay, thank you.
Yeah, correct. So now let's go back to the previous statement or previous slide. Read it again. Read the last point. Now this should be cleared. So task is executed by a thread. What is the thread? Executor core, and it is part of executor process. Where is this executor running? It's running on the worker node in the cluster. Let me ask you one interview question here. What is the difference between executor and executor core? A lot of people get confused here, but I'll make it clear for you. So as I told, executor is nothing but a Java or JVM process, right? You can think of it as a YARN container running on one of the slave machine. What about executor core? As I told, executor core is a subpart of the executor. It is nothing but a thread of the executor process. It is a thread started by the executor process. So each thread normally occupies one CPU core, right? If there are 4 cores on a given worker machine, it can execute up to 4 tasks. So sometimes you might have heard people saying, okay, I have octa-core based laptop. That is, there are totally 8 cores, which means 8 threads can run in parallel. Each thread can work on different tasks simultaneously. So that's why octa-core based laptops are faster than quad-core based laptop, because quad-core is nothing but max to max you can run only 4 threads at a time. Each thread will take care about one task. Hence, octa-core based laptops are faster than quad-core. So coming back to the point once again. So if there are 4 cores on a given worker machine, it can execute up to maximum of 4 tasks. So in short, executor is a Java JVM process. Executor core is the thread started by the executor process. I'm trying to put everything together. You have the master machine. On the master machine, you have the driver running. Of course, you have the Spark context. On the worker machine, you have all the slave daemons running. With respect to name, with respect to HDFS, data node is running. With respect to Yarn, node manager is running. With respect to Spark, executor is running. Right? And then you can see that you have the resource manager, and then you have the Spark context, which is going to act as a bit between your driver and then the resource manager. And then the executor cores are being occupied by the tasks, right? Tasks are running on the executor cores of the executors. So now if I talk about the Spark application execution lifecycle, so driver is the main program or the master daemon in Spark. In driver, you initiate the Spark context. We have already seen that, right? So you have the Spark context here. This is going to act as the bridge between your driver and then the cluster resource manager. As I told, cluster manager, resource manager, both are synonyms. People use this interchangeably. And we can use Yarn or Mesos or standalone cluster manager or Kubernetes as your resource manager. And a given Spark job has been broken into stages. Stages are further broken down into tasks. Tasks are executed on the workers. Again, based on what the job is divided into stages, based on what stages are divided into tasks, we will see that practically. But for now, just remember this hierarchy. Right? So the cluster manager takes a decision on which task should run on which worker machines. Right? As I told, worker machines are nothing but the physical machines. Within those, we have the executor, JVM or Java processes that are running. Now, you must be wondering how the driver and executors are connected. They are connected via this port. Executors register with the driver via a port called a spark.driver.port. And after driver and executor registration is done, driver will send those tasks and the application code to the executors. Now each executor will have multiple cores as I told, and it can be changed later on also. Each core is called as executor core. If there are 4 cores on a given worker machine, it can execute up to 4 tasks maximum. And once the Spark job is completed, the results are sent back to the driver application or results are saved back to the HDFS again. So let me put everything together. Let me try to summarize what we learned today. So application is nothing but your entire project, which can be packaged as a single file by using jar. And we have the driver. Driver is nothing but the master daemon in Spark. And we have the cluster manager. It can be standalone cluster manager, Mesos or Yarn, or even Kubernetes as well. And worker node is nothing but the physical machine. On that physical machine, we'll have multiple executors running. Executor is again a JVM or Java process. Where are these executors running? So let me use a different marker here. So you have your worker node. You have your worker node. On a given worker node, you have the executors running. And Spark job has been broken into stages. Stages are broken into tasks. Tasks are running on the executor core of the executor. Where are these executors running? These executors are running on the worker nodes in the cluster. So guys, based on today's session, I've got 10 interview questions for you. What I would suggest is go through this recording once again, come back to these interview questions and try to answer these. Of course, I'll be providing answers in a separate file so that you can cross check. And I have one assignment for you. The assignment is set up Spark on your laptop. Of course, I'll be providing a recording for you. So just follow that recording and you should be able to set up Spark on your laptop. So please make sure to set up Spark by tomorrow because it's going to be pure hands-on from tomorrow. Okay. So before wrapping up today's session, anybody have any questions so far? Feel free to ask. Any questions so far? As I told, every session is important from today. Please don't miss at any cost. Any questions so far? Okay, I think we are good then. Let us meet tomorrow. See you. Bye.
Thank you.